Alright, so this is my local DNS Attack Demonstration Lab, and how I'm going to do it is we're going to go through the lab manual on the left side. On the right side, we're going to have the 3 VMs. Here we have the user VM, then we have the server VM that's going to be used as the DNS server, and then we have the attacker VM. So let's go ahead and get started. So for task 1, we configure the user machine. So we have the user machine right here, and we're going to go ahead and run this command. Okay. Gotta do nano. So here's the file that it wants us to edit, so we don't have to worry about DHCP. So we added the name server with the IP address of the name server being 10.0.2.4, which is going to link us to our server IP address, which is seen right here with the 0.2.4. So we're going to exit out of that, did those changes. And then I already ran this command, the sudo resolve conf -u, so the changes are already in effect. And to show this, we're just gonna go ahead and run the dig command with google.com to show that it came from our server. So here you can see the server that I used for this was our DNS server that we set up, which is just our server VM. And as you can see, we got a response from it. So yeah, so task 2, setting up the local DNS server. So we had to move on to our server VM, and it wants us to modify this file right here. So for this file, it wants us to have the dump file set to this directory, and then it wants us to disable DNS security. So we went ahead and commented that out, and then it wanted us to dump the cache and flush the DNS cache, which we'll do in a bit here to show what it is, and then restart this DNS server, which I already did, but we can go ahead and look at the dump the cache to this file that it wants us to do, and then flush, and then we're gonna restart the server. But we already did that, so I'm not gonna show it just in case it messes anything up. I don't think it will, but just in case. So use the DNS server. So it says go back to your user machine and ping a computer, such as, which is the same thing that we did over here. We can now start using the DNS server for phone command. And it also says to use Wireshark. So here we have Wireshark. We'll go ahead and start the capture. Just go ahead and use the dig command. Oh, it wants us to use the ping command, my fault, which is not what we did earlier. So let's just go ahead and ping Google. And we gotta start getting replies, cancel that. Then we go to Wireshark, stop the capture, and you can see that for the DNS, for the request, it went to the 10.0.2.4 server IP address, which is the server VM, and then it responded. And then once we go down here, we can see the ping replies, echo ping requests, and then here we see the replies. pretty sure. Yeah, replies. Oh, print request and the replies, and then request and the reply. So yeah, that is task 2 of setting up the local server. And now we want to host a zone on the local server. So we go back to the server here. It wants us to modify this file right here to set up the zones. /name dot configuration. So I commented it out because what you want to do is, at first I was doing it in this file, but I went ahead and commented it out, and it says right here, if you're just adding zones, please do that in the named.configuration.local file. So we're going to go ahead and go to the local file, local instruction file, and here we have the zone setup that it wants you to do. I have it right here, as you can see. Go back and then set up the forward lookup zone file. So go ahead and look for that. /example.com/t. Whoops. And here we have the file that it wants us to make for the forward lookup. The IP addresses that it wants us to include, and then it wants us to set the reverse lookup. So instead of that example.com file, we're going to go to 192.1.0.db, and then here's the reverse lookup file. So we go ahead and go back, and then restart the bind server and test. So it wants us to restart it here, and then restart. And then go back to your user machine, and then it wants us to do the dig of www.example.com. And there we have everything we set up in the other files, the forward lookup, and then the backwards lookup, the reverse lookup. Yeah, if we do the reverse lookup, it would be 192.168.2. Yeah, there's a response. So moving on to the attack on DNS, first we're going to do is modify the host file. So basically we're going to act like we already have access to the machine from the attack machine, from the attacker. So it's saying you can modify the host file and reconfigure the IP address that the domain is linked to. So it wants us to redirect www.bank32.com to any IP address we chose. But then we'll take compare results before and after results. So before this, so it wants us to compare before and after. So this is before. So we'll go ahead and connect to our user VM and go to I was forgetting. Okay. So before it's 120. It's the bank32 domain is linked to 127.0.0.1 IP address, which is our local host. So it's just gonna pull up our local host webpage, which is the server is down for that right now, so it's not gonna pull up anything. But after I set the domain to 172.217.15.100, which is actually one of Google's IP addresses. So if you go ahead and, so if that's all set up on the user machine, and the user goes to Firefox, right, and types in, I already have it set up here, and types in the bang32.com website, it's going to redirect them to Google and say that's an error, like it wasn't found on this server, which that's what it should do because this page doesn't exist on Google. So, but that's the redirect modifying the host task. And for task 5, for directly spoofing a response, so in this, the user is going to ask for a response from the DNS server, but instead of getting a response from the DNS server, our attacker is automatically going to sniff the request and spoof the response. So we're going to use NetWalk's tool 105 here to do that, which is a sniffing and spoofing tool for DNS. So what we're going to do is, I have the commands over here. So this is the command. Hosts. Alright, this is the command to send a direct spoof response to the user. So we're gonna go ahead and start this. It's good. The program's running, or this command's running. Go ahead and clear the cache real quick from the server, and then we're gonna do www.example.net. And so we asked for the IP address of example.net, and it's 10.0.2.5, which is actually our IP address of our attack machine, as you can see right here. So that's what we want. We want it to redirect to our attacker machine. And this worked because we set that up over here. See, we linked the domain example.net to 10.0.2.5, which is our attacker machine. And the rest of the command is, this is the authoritative server, and then we have the DNS VM right here. And the filter is set to all hosts that are coming, all the packets that are coming from the host, from the user IP 10.0.2.15, and coming, and the destination port is 53, which is the DNS port. So there we directly spoofed the response to the user. And then for task 6, it wants us to actually directly cache poison the attack. So instead of directly attacking the user, we're going to attack the server, the DNS server that we set up. So before that, we're going to go ahead and clear the cache again, the DNS cache, and we're going to run this command right here. And then we go ahead and start Wireshark before we run this. Run the same command. Hold on. Did not work. Let's see here. Oh wait, that's not the flush cache, sorry. This is the flush cache. And then we run the command and run that. Sorry, let's recapture it. Run the command. Okay, let's redo this. Okay, so flush, run the command. start Wireshark, and then okay, so what the objective of this task was to attack the DNS cache, right? So here we got the same response that we wanted. It linked us. The answer was 10.0.2.5, which is our attack machine. So to look at the cache to see if it actually went through the cache, we go to here, and then sudo. So here's our cache file, and then here you see right here the domain, and then the IP address is now cached in the DNS server. And then you can also see that in Wireshark, where if you look at the last response, you can see that the answer, where's the answer? The answer is, well, I want you to see if the attack worked, which it did, and then it said standard query response, no error. And then, yeah, you can see the answer right there. So moving on to the next task, which is task 7, the DNS cache poisoning. So we're going to target the authority section right now. So it works with multiple domains. So we're going to attack the name server. So right now, what we're going to do right now is we're going to go to attack, and we're going to take a look at the code that it wants us to use for this. So I'm pretty sure I'm at DNS Attack. So this is the code that it wants us to use. So as you can see, for NS count, which is the authority section count, we're going to have one response, and that one response is going to be this right here, the NS sec1 response, which is this right here, what it wants. And then we're going to set the additional section response to 0 because we don't want additional section yet. And then we only want one response from the authority section. So we can go back and close this. We can run it. Let's flush the cache. Rerun Wireshark, run the capture, rerun the command. And here you can see we got the response that we wanted in the authority section. For example.net, the name server is now linked, is now attacked, and the domain is attacker32.com, which is what we set it to from our attacker VM. As you can see here, it sent one packet. And looking at Wireshark, you can see right here that attacker 32 came from the DNS server, so we successfully attacked it. So here we're going to target another domain for task 8. So we go back to task, we go back to our attacker VM, and now we're going to take a look at the DNS task 8.py code. So it's pretty much the same code. All that's going to change is for the second authority section response, we're going to have google.com, which is over here, and it's going to link it to the same name server, which is attacker32.com, which is the name server we want to redirect it to. And then, so we also changed the value in NS count, so instead of one response, we're going to get 2 responses, and we're going to keep the same 0 for the additional section because we don't need that yet. So let's go back here, let's run it. DNS task 8.py. Let's flush the cache, and then run the command. And here we see example.net. The original from the last task is still there, and then we have google.com from this task. So we targeted another domain in this case. And then it's attacker32.com. So we successfully did that task. And now for the last task, task 9, we're going to target the additional section. So let's go back here and look at the code for that. Task 9. Oh, whoops, I accidentally ran it, but we want to look at it first. So here, same structure of the code, but we're going to use this section now. First section, attacker32.com. Second section, ns.example.net. Third section, facebook.com. And those are the IP addresses that it wants us to do. And what we're going to change here is we're going to change the 0 to a 3 because we want 3 responses from here. So we go ahead and run this. Flush the cache. And the additional section, we got the responses that we wanted. We targeted the additional section. We still have the authority section targeted, and we still have the DNS. We still have the original example.net go into our attacker VM, and then it wants us to know if it was successfully cached or not. So let's look, dump it to the file, look at the file. So when I was going through this lab, I saw so here's the dump. Saw that it wasn't successfully cached. I want to say that's because we weren't directly attacking the cache in this one. We were just spoofing the response. So the entries weren't successfully cached in the DNS server. But yeah, that is my lab, my local DNS lab. And those are the tasks. Thank you.